Hey everyone, ready for a deep dive into something truly mind-blowing?
I hope so.
Today we're going to explore the radical idea of engineering spacetime.
Oh, wow.
Yeah, we're talking about manipulating gravity and energy,
Yeah.
like at the most fundamental level,
Okay.
using quantum entanglement. Our sources are all this cutting-edge research and emerging theories in quantum physics.
Sounds pretty out there.
I know, right?
It might sound like science fiction.
Yeah.
But the implications are huge. We could be talking anti-gravity, near-lossless energy transfer.
Wow.
Even tapping into zero-point energy.
What the fascinating thing is that this all hinges on the idea that space-time itself might emerge from quantum information.
Whoa, okay.
And if that's true, then maybe, just maybe, we can manipulate that information to control the very fabric of reality.
Okay, I'm hooked. But let's back up for a second. How can information like ones and zeros be as fundamental as mass and energy?
Think about Einstein's famous equation. You see that say?
Everyone's favorite. Right. It shows us that energy and mass are interchangeable. Now imagine information being added to that equation. What if manipulating information could influence gravity and energy just like we manipulate mass and energy?
Okay, so you're saying that information is the key.
Exactly.
But how do we go from, like, information on a computer to actually controlling gravity or generating energy?
One word. Entanglement. You see, the amount of information you can pack into a space is limited by something called the Bekenstein Bound. It's like a cosmic rule. Now imagine creating a dense network of entangled particles, a lattice that pushes against that limit. Some theories suggest this information pressure could actually warp space-time, creating gravity.
So instead of a planet, we could have this, like, super dense, information-rich lattice creating a gravitational field.
Exactly. And it's not just about creating gravity, it's about controlling it. Imagine being able to tune the entanglement of this lattice, making the gravity stronger or weaker, even changing its direction. Think anti-gravity devices, or even something like inertial dampeners for spaceships.
Okay, whoa. We're talking about controlling gravity with information, like adjusting a dial. That's incredible. But what about the energy side of things? How does entanglement fit in there?
Think of these entanglement lattices as information circuits. They can regulate energy flow in ways we can barely imagine. For example, there's this concept called quantum throttling.
Quantum throttling.
Yeah, where information bottlenecks control energy flow, much like semiconductors control electrons.
Okay, I'm following.
This could lead to near-lossless energy transfer.
So instead of losing energy as heat, it would flow perfectly through these information circuits.
Right.
That sounds like a dream come true for efficiency.
It gets even wilder. There's also the possibility of coherent energy amplification.
Okay, what's that?
Well, each node in the lattice acts as a multiplier, boosting energy as it flows through. We might even be able to tap into the energy of quantum fluctuations themselves. Zero-point energy.
Okay, now we're talking about potentially limitless clean energy. This is amazing. But how do we actually test these, like, mind-blowing theories? Is there any way to experiment with these ideas?
Absolutely. There are a few key experimental pathways. One approach is to actually build these hexagonal entanglement lattices in a lab and measure any minute gravitational changes they induce.
So, like, creating a tiny artificial gravity well.
Yeah. What would that even look like? Well, we're talking about very subtle effects, but we could use incredibly sensitive instruments like atomic clocks to measure tiny shifts in time dilation, which is influenced by gravity, or we could use laser interferometers.
Wow.
The same technology used to detect gravitational waves, to look for fluctuations in space-time caused by the lattice.
Wow, it's amazing to think we could create and measure these effects in a lab. What about testing the energy flow ideas?
For that, we could construct special waveguides made of metamaterials that mimic the structure of these entanglement lattices. If we see energy flowing through these waveguides with significantly less loss than in traditional materials, that would be strong evidence that we're on the right track.
So these experiments could provide the first real glimpse into the world of engineering spacetime.
Exactly. We're talking about a potential paradigm shift in how we understand and interact with the universe.
This is all so fascinating. It feels like we're just scratching the surface of something truly revolutionary. Before we move on, though, I want to make sure we connect all this back to you, our listener. What are the key takeaways here? Why should you care about this?
Well, imagine a future where we can control gravity like we control electricity. A future where clean energy is practically limitless. A future where space travel is revolutionized by inertial dampeners and anti-gravity drives. That's the potential we're talking about here. And these experiments are the first steps towards realizing that potential. It really is. And remember, we're not just talking about theoretical concepts here. We're talking about real experiments that are happening right now. Experiments that could pave the way for these incredible technologies.
Okay, I definitely want to hear more about those experiments, and especially the ones focused on gravity manipulation.
Yeah.
Building a miniature gravity well in a lab sounds insanely ambitious.
It is. But think about the potential payoff. Imagine being able to create a localized gravitational field right here on Earth.
Yeah.
We could study its effects on different materials,
Right?
test new propulsion systems, maybe even simulate the conditions around a black hole.
That's wild, but how do you even begin to build something like that? We're not talking about just stacking a bunch of heavy objects together, right?
Right. It's all about manipulating information. Remember those hexagonal entanglement lattices?
Mm-hmm.
The idea is to create a lattice so dense with entangled particles that it starts to warp space-time around it, creating a measurable gravitational field.
So we're essentially building a structure out of pure information that acts like a massive object.
Yeah.
That's mind-blowing. What kind of particles would we use to build this lattice?
There are a few possibilities. We could use photons, which are particles of light, or electrons, which are fundamental particles that carry electric charge. We could even use ultra-cold atoms in a state called a Bose-Einstein condensate, which is a collection of atoms cooled down to almost absolute zero, where they all behave like a single quantum object.
So we'd be manipulating these particles at the quantum level to create these intricate entanglement structures. That sounds incredibly challenging. What are some of the biggest hurdles in actually building these lattices?
One of the biggest challenges is maintaining the coherence of the entangled state.
Okay.
Entanglement is very fragile. Any interaction with the environment can cause the entanglement to collapse, and we lose the effect.
So it's like trying to build a house of cards in a hurricane.
That's a great analogy. To protect the entanglement, we need to isolate the particles from any external influences. This could involve using extremely low temperatures, special materials that shield the lattice from electromagnetic interference, or even manipulating the quantum vacuum around the lattice to reduce fluctuations.
It sounds like building these lattices requires pushing the boundaries of material science and experimental techniques. What about actually measuring the gravitational field produced by the lattice? How do we know it's working?
As I mentioned earlier, incredibly sensitive instruments like atomic clocks could help us detect minute changes in time dilation,
Right.
a phenomenon influenced by gravity. We could also use laser interferometers to look for tiny ripples in space-time caused by the lattice's gravitational field.
So we'd be looking for tiny, almost imperceptible effects, but if we see them, it would be a huge confirmation that we're on the right track.
Exactly. And imagine what we could learn if we could create these controlled gravitational fields. It would open up entirely new avenues of research in physics, astronomy, and even engineering.
Okay, let's shift gears for a moment and talk about those energy experiments you mentioned.
Yeah.
You talked about constructing special waveguides that mimic the structure of entanglement lattices. Can you explain that a bit more?
Sure. Imagine a traditional electrical wire. Some energy is always lost as heat due to resistance in the wire. Now imagine a waveguide where energy flows with almost zero resistance, thanks to the unique properties of the entanglement lattice structure. That's what we're trying to achieve.
So we're talking about potentially revolutionizing energy transmission with these waveguides. No more energy loss, almost perfect efficiency.
Exactly. To test this, we would build waveguides out of carefully engineered metamaterials that mimic the entanglement lattice structure. These metamaterials have unique electromagnetic properties that we can tune to control the flow of energy.
And how would we actually measure whether the energy is flowing with less resistance in these waveguides?
We would send a pulse of energy through the waveguide and measure how much energy comes out the other end. By comparing this to traditional waveguides, we can see how much energy is lost and determine the efficiency of the entanglement-based waveguide.
So if we see a significant difference in energy loss, it would be a strong indication that the entanglement structure is influencing the energy flow in a positive way.
Precisely. It would be a major step towards realizing the potential of engineering space-time for energy applications.
This is all so incredibly exciting. It's like we're on the cusp of unlocking a whole new level of understanding and control over the universe. But I have to admit, it also raises some big questions. For example, if we can build devices that manipulate gravity and control energy flow at such a fundamental level, what are the potential risks? Could these technologies be misused?
Those are very important questions, and they're ones that scientists and ethicists need to address as this field advances. Any powerful technology can be misused, so it's crucial to develop safeguards and ethical guidelines to ensure responsible development and use of these potentially revolutionary technologies.
You're right. It's all about finding that balance between pushing the boundaries of science and making sure we use our knowledge wisely. This deep dive has been a mind-blowing exploration into the potential of engineering space-time, but it feels like we've just scratched the surface.
We have, and remember, this is not just a theoretical exercise. Real experiments are happening right now that could change our understanding of the universe and our place within it.
It's truly an exciting time to be alive. But before we wrap up, I want to connect back to you, our listener, one last time. We've talked about manipulating gravity and controlling energy flow. But how does this actually impact your life?
Right.
Well, imagine a world where energy is abundant
Oh, wow.
and accessible to everyone thanks to these near-lossless transmission systems.
That's
A
amazing.
world where space travel is no longer a distant dream, but a tangible reality because we figured out how to control gravity.
I would change everything.
I know, right?
Yeah, it's mind-blowing.
Those are just some of the possibilities. But to get there, we need to keep pushing the boundaries of science and
Right.
exploring these mind-boggling concepts. And that's what's so exciting about the research happening right now.
Mhm.
It's not just theory anymore.
Mm.
It's experimentation, exploration, and the potential for groundbreaking discoveries.
It really is a fascinating time.
And that's what we've tried to highlight in this deep dive, the incredible potential of engineering space-time and the fact that we're already taking those first steps towards making it a reality.
Yeah.
But before we wrap up, I have one last question for you.
Okay.
It's a big one.
Mhm.
And I'm not sure there's even an answer yet, but it's something I keep coming back to.
I'm intrigued.
We've talked about the how of engineering space-time.
Yeah.
But what about the why?
The why?
What's driving this quest to manipulate the most fundamental forces in the universe? Is it simply the pursuit of knowledge, the insatiable human curiosity to understand how things work?
Uh-huh.
Or is there something deeper, a desire to transcend our current limitations, to reshape reality itself?
That's a profound question, and one that probably has different answers for different people.
Yeah, I bet.
For some, it might be the pure thrill of scientific discovery, the
Wow.
challenge of pushing the boundaries of what we know
Yeah.
and what we can do.
For others, it might be the hope of solving some of humanity's biggest challenges, like finding clean energy solutions or enabling interstellar travel.
Exactly. But I think there's also a deeper element at play here, a fundamental human desire to understand our place in the universe,
Oh, I like that.
to grasp the nature of reality itself, and perhaps through that understanding, to gain a level of control that has always seemed beyond our reach.
It's like we're reaching for the stars, not just literally, but metaphorically, trying to unlock the secrets of the universe and harness its power for our own purposes. But as with any powerful tool, we need to be mindful of the responsibility that comes with it.
Absolutely. The ability to manipulate gravity to control energy flow at such a fundamental level. It's a power that demands caution and ethical consideration. We need to ensure that these technologies are developed and used responsibly for the benefit of all humankind.
It's a reminder that the pursuit of knowledge should always be tempered with wisdom, in a sense of shared humanity. And that's a good note to end on, I think. This deep dive into engineering space-time has been an incredible journey. It's a topic that sparks the imagination and challenges our understanding of what's possible.
And it's a topic that's only going to become more relevant as science continues to advance. Who knows what the future holds, but one thing's for sure. It's going to be an exciting ride.
It certainly will be. To all our listeners out there, thanks for joining us on this deep dive. Keep exploring, keep questioning, and keep pushing the boundaries of what you think is possible. Until next time.